as of now, I defined a new scale in honor of this object that is called the Loeb scale after my last name, with 0 meaning it's a natural object, like a comet, for sure. And 10 meaning it's definitely a technological object because in case we, for example, see a maneuver or we see some artificial lights emitted by it or we get some message from it. As of now, I would rank it as 4, given all the anomalies that I mentioned. And of course, the fun thing of doing science is that it's work in progress. It's a learning experience. The more data we get, the better assessment we will have as to the nature of this object. The rank will either sink to 0, where we will figure out it must be a comet, or will rise all the way to 10, in which case the stock market may crash.
Avi Loeb is the Bird Professor of Science and the Director of the Institute for Theory and Computation at Harvard University. And he's well known for his groundbreaking work on extraterrestrial life, on black holes, and the Oumuamua object. He's also the best-selling author of Extraterrestrial and Interstellar, books about intelligent life beyond the Earth. So thank you for joining me, Professor Loeb.
My pleasure. Thanks for hosting me.
Tell me, in 2017, Oumuamua, which is the first known interstellar visitor, visited us. And now, 5-7 years later on, we now have another one. This is the third one that we're aware of, and it's called 3I Atlas, I understand. And right. It's due here in October to December kind of time. Can you tell us something about it?
Yeah, well, as soon as that one was discovered, I estimated the size of this object based on its brightness, and turned out to be 20 kilometers in diameter if it's a solid object. And that's huge. That's twice as large as the asteroid that killed the dinosaurs. And these are extremely rare rocks. In fact, even if you take all the rocky material in interstellar space and package it in rocks of 20 kilometers in size, you will be able to provide the inner solar system with such a rock once every 10,000 years.
Wow.
So there is just not enough material to deliver us a giant rock of this size over the period of roughly a decade that we surveyed the sky with the Atlas telescope. And moreover, there is no cometary tail behind this object. In fact, the Hubble Space Telescope imaged it with the best angular resolution, and we see some glow in front of it, but nothing trailing it. And then the light, the reflected sunlight is reddened. But if it was reddened by dust particles, if this was a much smaller object surrounded by a cloud of dust, then these dust particles that redden it would also be pushed by solar radiation pressure behind the object. We don't see that. So it's possible the glow is a result of much bigger dust particles that are not reddening it because they are so big, much bigger, longer than the wavelength of the light, the sunlight. But in that case, it means the object is too large. And there is no evidence for gas of the type that you find around comets. So the question of whether it's a comet or something else is really intriguing. Because one way to resolve the mass budget discrepancy is to say this object was targeting the inner solar system, and as a result, it has nothing to do with the reservoir of rocky material. It was designed to visit us. And indeed, the trajectory of this object is very fine-tuned. It lies in the plane of the planets around the sun to within 5 degrees, and the chance of that happening is 1 in 500 or so. And then even along the same path that it takes, the timing of its arrival is fine-tuned to within 1 part in 20,000, such that it will pass close to Mars, Venus, and Jupiter as they move around the sun. And it comes on a retrograde orbit, and it will be closest to the sun when we can't observe it. The Earth would be on the opposite side. So that is the point in time when it can do a maneuver or release mini probes that will visit the planets. And so it just looks unusual. It also came from a direction where it's hard to find it, this region of the center of the Milky Way galaxy that is crowded with stars. And my point is we should monitor it because as of now, I defined the new scale in honor of this object that is called the Loeb scale after my last name, with 0 meaning it's a natural object, like a comet, for sure. And 10 meaning it's definitely a technological object because in case we, for example, see a maneuver or we see some artificial lights emitted by it or we get some message from it. As of now, I would rank it as 4, given all the anomalies that I mentioned. And of course, the fun thing of doing science is that it's work in progress. It's a learning experience. The more data we get, the better assessment we will have as to the nature of this object. The rank will either sink to 0, where we will figure out it must be a comet, or will rise all the way to 10, in which case the stock market may crash. And my point is, the best way to distinguish between a dogmatist and a scientist, a genuine scientist, is to give them a lot of data. The dogmatist will worry that the data may falsify the dogma. A real scientist would always be happy because even if it changes our views, we learn something new.
Yeah. Tell me about this Loeb scale. When you say you rate it a 4, because I was going to ask you what you think the probability of it being an artificial object is. When you rate it a 4, are you saying that it's a 40% chance of it being artificial?
Yeah, roughly speaking.
That's very high.
That's pretty high. I actually defined the different numbers between 0 and 10 in a paper that I co-authored. And I explained what each number means. And a 4 means that it's on the threshold of being considered seriously as a technological, but it's not yet there. We haven't seen the generic signature of a technological object. And if we do, then it will be a matter of policymakers in consultation with scientists how to respond, because that's very different than getting a radio signal from a star that is thousands of light years away, in which case there is no rush in responding to it. But when you have a visitor to your backyard, there is urgency in responding appropriately. And, we discussed in the past the existential threat from artificial intelligence, from climate change, from an asteroid impact, but there was no discussion about alien technology. And I think we should keep that in mind now that we're entering a new era where the Rubin telescope in Chile will find a new interstellar object every few months.
Okay. Now, your suggestion that this has the potential, 40% potential, of being some alien artifact, does that get much pushback from your fellow academics? What kind of response have you had from that?
Oh, definitely. A lot of pushback, and some of it is personal, which I find puzzling because, when I signed up to become a scientist, I assumed that, it should be driven by curiosity. All questions should be on the table. Science is not supposed to censor questions. The scientific method is not about censoring questions. It's about using data and evidence to answer them. That's the scientific method. And instead, what you see is people guessing the answer or assuming that it represents past knowledge, traditional thinking, and they are hostile to any possibility that it might deviate from the beaten path, that this is a new type of object. And I find that counterproductive, because if we assume we know the answer in advance, then we will bend any evidence that we get in that direction. Just to give an example, people see this image from the Hubble Space Telescope and they say, obviously there is some glow around the object. It looks as if it's a comet, but they're assuming that it's moving away from the the glow, and in fact, it's moving into the glow, which is very different than most comets. Usually you see a cometary tail behind them. Also, the scale of this glow is 2 orders of magnitude smaller. It's very compact, barely visible with the resolution of the Hubble Space Telescope. It's 2 orders of magnitude smaller than that around the interstellar comet 2I Borisov that we discovered in 2019. There is no evidence for any molecules that were seen in the case of Borisov, and yet people say, oh yeah, it's a comet, forget about it, let's move on. And I find this dismissive attitude, counterproductive, because obviously if we don't agnostically examine the data, we will never find anything new. And there are several examples of that. For example, in January 2nd this year, the Minor Planet Center cataloged a near-Earth object as an asteroid. And then a day later, they realized, oh, that one actually moves along the trajectory of the Tesla Roadster car that was launched by SpaceX. So it's not a rock, it's a car. And it just shows you that very naturally, astronomers can catalog technological debris or objects as rocks of a type that was never seen before. And therefore, we should be really careful, because for the objects that we launched, we can figure out it's a Tesla car, it's not a rock. But what about those launched by our neighbors? And why should we assume that our neighbors are less capable than we are? My point is, Elon Musk is not the most accomplished space entrepreneur since the Big Bang, 13.8 billion years ago. Let's be open-minded. Let's look for unfamiliar objects. And here we have one of them, 3I Atlas. It's a blind date. And in blind dates, especially those from interstellar space, we should observe before expressing an opinion about the nature of the other side. And so that's my advice.
What do you say to the people who propose that, the Fermi paradox? Enrico Fermi was well known as suggesting that there were no real aliens out there because, he said, we would have seen them by now. What's your comment on that?
Right. So one solution to that paradox is called the dark forest hypothesis, where they exist out there, but those that survived are careful, they're silent to avoid predators. And they were bruised by encounters in the past, and therefore they just observe rather than make a sound. We were careless. We were broadcasting radio signals for more than a century, and those signals must have reached them. So at some point, if they see us as a threat, because we are a young technological civilization, they might visit us. And for example, 3I Atlas took about 8,000 years to reach us from the outskirts of the Oort cloud of the solar system at 100,000 times the Earth-Sun separation. And that was, 8,000 years ago. That's when humans started to document their history. That's not very long ago. And if this is a spacecraft, if it started its journey about 1,000 times the Earth-Sun separation, then it would have taken it 80 years to reach us. That's roughly the period over which modern science and technology were developed. So we just don't know if it's technological, where it came from, and what the objective is. But the point is, we made our existence known out to 100 light years from Earth. And so we shouldn't be surprised that if someone is out there, they might visit us without making a signal. By the way, even a craft that is tens of kilometers in size cannot be observed with our best telescopes beyond a distance of 10 times the Earth-Sun separation, because it doesn't reflect much sunlight. So we just don't know what is out there. We assume that it's empty space, and some people argue very vigorously that we are the smartest in the universe. This pride that is not justified, and I can sort of understand it, because my daughters, when they were young, they thought that they are the smartest and at the center of the universe, because their training data set was limited to home. They didn't know much beyond, and they had a shock when they went on the first day to the kindergarten, seeing other kids just like them. My point is that it's a sign of immaturity. That humanity did not mature, and my colleagues in academia did not mature. They still believe that it's an extraordinary claim to imagine something like us elsewhere. And I say, no, it's an ordinary claim because there are lots of Earth-Sun analogs. There are billions of them in the Milky Way alone. And therefore, we shouldn't be surprised if someone comes to visit us.
The nearest one is what, Alpha Centauri?
That's the nearest star. But the question is, you could have a visit from the other end of the Milky Way galaxy. The Voyager spacecraft that we launched within 1 billion years would be on the opposite side of the Milky Way disk.
It's a long time, though, 1 billion years, isn't it?
No, it's not, because most of the stars formed billions of years before the sun. The sun is a late comer. We are late to the party.
Right.
The sun formed in the last 1/3 of cosmic history, and most stars formed billions of years before the sun. So if you start the technological clock exactly as happened on Earth, but a few billion years earlier, they had plenty of time to reach us from all across the Milky Way disk of stars. And therefore, the question is, when did they start the journey? They could be very nearby if they reached, if they started the journey billions of years ago.
There are two views about first contact expressed in movies these days and common media. So there were movies like The Day the Earth Stood Still and Star Trek, who welcome first contact. They say there's a benign presence out there. They'll come, they'll bring helpful technology if we ever meet them. And yet there's this other view, too, of it being a dangerous act. The movies like Independence Day and Alien, which say that it's an existential danger to us. Do you take one of those views?
Well, actually, Stephen Hawking, the physicist, more than a decade ago, and he was at my home on a visit about 9 years ago. Yeah. He argued that, in fact, we should be very careful because we don't know what is out there, and because it could be an existential threat. The point is, we were careless so far. Now, as to whether there is a threat or not, that depends on who visits us, and we have to judge each visitor by its qualities and its intent. We cannot decide about the global policy to all visitors because it's similar to a visitor to your backyard. And some visitors are friendly, some are hostile. You really need to judge it by the case. The risk is a Trojan horse, something that looks very friendly and ends up being a real threat. And that's why we should be careful as to how we respond. There was a tsunami just a couple of weeks ago, and all that the governments could say is to tell their citizens, be careful. They could not protect their citizens against the tsunami. And if you think about a threat from the sky, they have no way of protecting citizens. So it will cause a lot of geopolitical unrest, and economic markets will be heavily affected by the news that we are not alone, that there might be a smarter kid on our block. And with respect to how we should respond to that, there needs to be an international organization of policymakers that take all the data into account and make a decision that all humans should abide by, because we are all in the same boat. As to whether it's an imminent risk or not, that depends on what comes our way. And, so I don't want to make any general statements. It's a case-by-case basis.
Yes, but do you personally believe that there is certainly, almost with a 100% probability, that there is some alien life out there?
Definitely. And that's out of a sense of cosmic modesty. I just don't feel that I'm exceptional. I read the news every day and I see that there is a lot of room for improvement. Human intelligence is not the pinnacle of creation.
Okay. If these other stars have been around for 1 billion years or more longer than us, yes, do you think it's possible that we have already been visited, yes, and we just missed it?
Yes, definitely. I mean, humans existed on Earth just for a few million years. And that's less than 1 part in 1,000 of the age of the Earth. And the Earth went through many major events before humans came to the scene, and who knows, maybe they were facilitated by some interstellar gardener that came and visited and introduced intelligence to Earth, for example, or something. We just don't know. And I think we should be open to that possibility. And for now, we should simply search and check. Now, it's not just a matter of time that they were longer than we did and so forth. It's also a question of the size of our brain. You know, we have an intelligence limited by the number of connections or parameters in the neural network that makes our brain. We can imagine creating an AI system that will have more connection, more parameters, and that will be superhuman in its capabilities, cognitive abilities. But when something even biological grows on another planet near another star, who knows what the limits are? For us, the size of the brain was dictated by power consumption. It currently consumes about a fifth of the metabolic power of the human body, you know, so it couldn't grow much bigger. But if you imagine an animal bigger than us that grew on another planet that had a bigger brain and more neural connections and more cognitive abilities, we might not understand this superhuman intelligence in the same way that a dog doesn't understand really the behavior of its owner. You know, if the owner goes to the post office to fill a passport application, and as a result, the dog doesn't get fed, then the dog will have no concept of the context for why it's hungry. And so, you know, if we are dealing with a superhuman intelligence, there might be things we simply cannot comprehend that they know about the physical reality, and they know how to manipulate it in ways that we can't. And, you know, there is clear evidence for that. For example, 85% of the matter in the universe, we call it dark matter out of ignorance. We just don't know what it is. And then on top of that, there is dark energy, which we don't know what it is. These are just examples where we see that we are ignorant. Nevertheless,
talking to Jim Peoples about that, and
yeah, and he got the Nobel Prize, by the way. So we give Nobel Prizes to people who realize how ignorant we are. Okay, and it's not as if they found what the dark matter is. We still don't know what it is after about.
No, that's right. He
50.
didn't know either. He didn't know.
Yeah. So my point is,
let me
yeah.
bring you back to 3I for a moment. It's hurtling on its way towards us. When will we know whether it is an alien artifact or just a natural phenomenon of some kind? What's the date we should be looking for to be able to fix some knowledge of it?
Yeah, so my hope is that by the end of September, within a month from now, it will get close to the sun. And if it's a comet, we should see it erupting in outgassing and creating a very thick plume of dust and gas around it that we can probe. And then, you know, if it behaves like a comet, I would use the duck test, which is if it quacks like a duck, walks like a duck, it's a duck, you know. So I would accept that. I would rank it 0 on my scale.
But hold on a minute. If you did have an alien artifact which had traveled for 1,000 or 8,000 years through the cosmos, wouldn't it have accreted some ice and some particles, so that it would actually act like a comet because of all the stuff that was on the outside of it anyway, without us knowing?
That's an excellent question. And in fact, yesterday I did some calculation and I realized that the current glow of dust around the object can be supplied or maintained for 6 months if you simply ablate a layer of 1 millimeter from the surface of the object, of a 20-kilometer object. It amounts to very little amount of dust or dirt, just a tiny, you know, a few millimeter thick surface layer could generate the kind of glow that we see. We don't see a big cometary tail that would require much more material, including ices. It may not be ice, it may be just the surface being eroded during the journey that it had before, and we see just those particles. It's a dusty object as a result of its journey through interstellar space.
Of course, the best way to find out about it would have been to be able to intercept it in some way, but it's traveling so fast, and we learned about it not so long ago, that intercepting was not really a feasible
Well,
plan, is it?
so what I realized, indeed, from Earth, we cannot launch a rocket that would reach it or intercept it because it will be moving at 98 kilometers per second at the perihelion, closest to the sun relative to Earth, because it moves in the opposite direction of Earth.
Yeah.
And that's a few times bigger than the fastest rocket that we can launch from Earth. However, I realized that it will pass very close to Jupiter in mid-March 2026. And around Jupiter, there is a spacecraft called Juno that was supposed to end its life in mid-September 2025. We were supposed to give it a push towards Jupiter where it will end its life, burn up, and disappear after mid-September 2025. And if instead of giving it a push into Jupiter, we give it a push away from Jupiter, I wrote a paper suggesting that it could actually, depending on the amount of fuel, get very close to the path of 3I Atlas in mid-March 2026. And a day after I wrote this paper, I had a phone call from Congresswoman Anna Paulina Luna, who asked me for an update about 3A Atlas. And then when I told her about this opportunity with Juno, she volunteered to write a letter to the head of NASA, encouraging NASA to look into the possibility of using Juno as a probe of 3I Atlas. So that would be our best bet. If Juno had maintained most of the fuel that it had originally, it could have intercepted 3I Atlas. But since it has less fuel left, it will probably just get within tens of millions of kilometers if we were to follow this plan. But this could still be much better than looking at the object from Earth, because perhaps we will learn something new from this close encounter. But that's our best bet as of now. There is also a possibility, of course, that some wealthy individual, in fact, I was speaking with some people that are close to wealthy individuals, for a cost of $500 million would fund an interceptor that perhaps by the end of 2026 will chase 3I Atlas and intercept it. But, it's a lot of money, and it's not clear to me that this will happen.
Right. Well, Professor Loeb, thank you very much for your time today and for explaining this subject. One last question. There is no chance of this ever impacting the Earth, is there?
No, unless it does a maneuver. And, and there could be two types of things it can do. Either itself maneuver or send mini probes that will intercept the Earth. So in that case, the second case, we might see activity a few months later from objects that arrive at the Earth's atmosphere. But it makes most sense for this object not to maneuver itself, because if it's a giant 20-kilometer object, it requires a lot of fuel to slow down and visit the planets.
Right.
And it makes more sense for it to maintain the precious infrastructure that it has for the next target. And so continue along the path and just leave a few probes that will inform it about whatever it wants to know about the inner planets that it passes close to.
Professor Loeb, thank you ever so much for a fascinating conversation on this unusual.
Thanks for having me.